Welcome to the EnergyTech University Explore event, everyone. We are so excited to have you here and to hear our university teams present their idea. First off, I'd like to introduce myself. I'm Chaya Kara. I'm a graduating senior from UC San Diego studying public health and entrepreneurship. I'm also the marketing and communications assistant at the UCSD basement. I'll be one of your MCs today. I'd like to start us off by playing a short video from Vanessa Chan, the Chief Commercialization Officer of the Department of Energy and the Director of Technology Transitions.
Welcome to the inaugural EnergyTech University Prize Competition. I'm Vanessa Chan, the Director of the Office of Technology Transitions, or OTT for short, and also the Chief Commercialization Officer of the Department of Energy. As a sponsoring office of EnergyTech Up, I can say that all of us here at OTT are humbled by the fact that we have seen a huge surge of enthusiasm from student teams, colleges and universities, incubators, and energy industry organizations. In fact, with 180 total applications from 113 schools, our inaugural cadre of teams represent 42 states, plus the District of Columbia and Puerto Rico. Not too shabby for our very first one. My thanks go out to my team at OTT, to the invaluable support we received from the National Renewable Energy Lab team, our partnering regional conveners, as well as the students themselves for their hard work. My vision for the goals and outcomes of this competition are: 1, to strengthen the energy innovation community across the US and territories; 2, to identify business opportunities for young entrepreneurs; and 3, to help lay a talent pipeline that will secure our energy future. We hope you all can take this opportunity to network and get to know the work going on in your region, because collaborators across schools catalyze future partnerships. Our mission at OTT is to help shepherd technologies through the research, development, demonstration, and deployment, or RD&D continuum, to ensure they are commercialized and brought to the market. You're about to hear several inspiring, innovative ideas to do just that. This is an exciting time to be a budding entrepreneur because a clean energy transition is upon us. It will be revolutionary for our world, and we need all hands on deck to make it happen. Today, you are all on deck to play a role as you think and work towards that future. The students of today are the innovators, scientists, marketing specialists, policymakers, and entrepreneurs that we need. So with that, good luck, and may the best business plan win. But not to be too cheesy, you guys have all won by participating, because this is what we have to do to go hit our climate targets. Good luck.
Thank you for that introduction, Vanessa. Next up, I'd like to introduce Paul Robin, the Associate Vice Chancellor of Innovation and Commercialization at UC San Diego. Paul will be giving us a few words about UCSD's involvement with EnergyTech.
Thank you, Chaya. So first of all, it's wonderful to be here. Welcome everybody to this fantastic event. I wanted to thank the DOE and our NREL colleagues for really putting on a fantastic national event. Hats off to you guys, particularly first time out. You've done a fantastic job on all of this. Not only raising visibility for energy technologies and the work of the national labs, of course, but bringing people together from all over the country. It's terrific. It's unusual that we would have 8 different universities, I believe, represented here from California. So, you know, we love to see that. And as Vanessa said, hopefully it'll inspire collaboration across the different institutes. UC San Diego, of course, was delighted to be able to convene this for the California area and bring this all together for you guys. And I'd like to thank the team here at UCSD. We had a number of people who screened all of the applications. And of course, we have the team here today, particularly Christine and Jacques and Chaya, who really have put a lot of effort into bringing this event itself together. So thank you guys for doing all of that. I want to congratulate all of the presenters. It really is a win for you guys to get this far. So congratulations on getting this far. I've read through all of the business plans, and personally, I think they all deserve an opportunity to be developed one way or another. And I'm sure that your home institutions would support you in that if that's what you choose to do. So good luck today in your presentations. And finally, I want to introduce the judges. We have a stellar panel of judges today. We have Mark Jurgensen from CleanTech Energy Inc., where he is Managing Director. We have Jackie Henberg, who is Director of Environmental and Permitting Services at DNV. Kristen Griffin, who leads Innovation and Technology Commercialization for EDF Renewables. Sounds like her job was similar to mine. And Eric Stokes, who is Deputy Division Chief for the California Energy Commission's R&D Division. This is an absolute stellar panel of judges, as I said, and collectively, I think they probably know everything there is to know about energy tech. So thank you, judges, for being here. We're honored to have you, and really can't thank you enough for taking your time. And I'm sure you're going to enjoy these presentations. And last but definitely not least, I want to introduce Marty Turok, who is Executive Director of the Southern California Energy Innovation Network and is one of our good friends at CleanTech San Diego and has been an incredible partner with us over the years, and who has also put a huge amount of effort and energy into this particular event as well. Without you, Marty, we couldn't have done this either. So thank you very much. And he, I believe, is going to lead us through the team presentations. Right, Marty?
Thank you, Paul. Thank you, Paul, and good afternoon, everyone. I am delighted to be here today representing CleanTech San Diego, our Scene Incubator, and the California Energy Commission's entrepreneurial ecosystem as a guest presenter for the California Region DOE Explorer event. And first off, I'd like to offer my congratulations to the university teams, not just for being selected to participate in this inaugural EnergyTech University Prize pitch competition, but because you are clearly amongst the best and the brightest of America's university students. And how do I know that? Well, because the fact that you are presenting a business model for a breakthrough energy technology demonstrates that you already recognize that the energy industry is undergoing a major transformation driven by decarbonization, decentralization, and digitization. And with virtually all of the world's major cities, countries, and corporations committed to achieving zero net carbon climate action plans and ESG goals by mid-century, this energy arena is clearly one of the best places to grow your career over the next 30+ years. So given the structure of today's pitch competition with 12 presenting teams and a need to give the judges some time in between the presentations to thoughtfully score the 10 primary evaluation criteria, I'm going to try something a little bit different today by delivering my presentation in 12 segments between each of the team presentations. And to build on the DOE's key objectives for this event, my comments are going to focus on raising your awareness to all of the technical, business, and financial resources that are available to help energy startups in California accelerate their pathway from campus to commerce. So let's get the show on the road with our first presentation team representing Stanford University. I'm delighted to introduce to you Catherine Berner, who's going to tell us about their Breeze tech-enabled refrigerant management.
Thank you, Marty. Today, I'm going to talk to you about the climate threat you've never heard of. This is a threat lurking in our fridges, our grocery stores, and our cars. I'm talking about refrigerants. Slide. Refrigerants are the gases used in air conditioners and fridges. These gases are 6,000 times more polluting than CO2. This means that refrigerants pollute more CO2 than the entire aviation industry. Let that sink in. These gases that we never think about pollute more than all the planes globally. Slide. Our team has completed hundreds of interviews in the space and identified 3 key tailwinds. First, this is a huge climate problem. Second, there are regulatory tailwinds driving better management practices. And third, reclaiming and destruction of refrigerants can be monetized in one of the fastest growing parts of the climate ecosystem, carbon markets. Slide. As we dug into this in more detail, we found there's an ideal system that is very different from the reality of what is happening out in the world. The ideal system is shown here before you. Refrigerants are supposed to flow from appropriate on-site reclaim by HVAC contractors to safe transport and ultimately safe disposal. However, in reality, HVAC contractors face key challenges when it comes to capture and disposal. Capture takes time, disposal is costly, and the whole process is incredibly opaque. Next slide. What this means is that all too often, there's an easier option for contractors, simply venting the gases to the atmosphere and moving on with their day. Slide. At Breeze, we're changing that. We're putting HVAC contractors at the center of our solution. We're creating a tech-enabled marketplace that will connect these contractors to carbon offsetting programs, allowing them to monetize best practice in refrigerant management. Breeze is a frictionless, cost-positive, and transparent solution for HVAC contractors. Slide. We are building a digital marketplace that accelerates the adoption of novel technologies for end-of-life management, leak detection and repair, and low global warming potential refrigerant systems. This reduces both the emissions from refrigerants themselves and improves the efficiency of HVAC equipment, greatly reducing the energy consumption for the cooling industry. Slide. And this market is wide open. Refrigerant management is a huge market globally. HVAC services is a $60 billion market, and HVAC repair is an additional $12 billion market. In the US, refrigerant sales alone is a $3 billion opportunity. Slide. And this giant market is undeveloped. There are two players, startups working in the space, Tradewater and Recool It. They're paving the way for carbon offset through refrigerant disposal, but their focus is geographically limited and unscalable. A-Gas is the sleeping giant in the space, focused on disposal, but not innovating on the collection. There is a tremendous value capture opportunity in the tech-enabled, scalable collection platform. Slide. At Breeze, we believe in a future with zero refrigerant emissions. We are building this future by unlocking the full potential of refrigerant management tech and solving the problems of HVAC contractors. Thank you very much.
Thank you, Catherine, and thank you to the Breeze team. Going forward with a little time for the judges and to continue a little bit of background, Cleantech San Diego was actually founded in 2007 with the mission of accelerating the adoption of best practices in sustainability to accelerate clean technology innovation and promote the equitable deployment of sustainable solutions across the San Diego region for the benefit of the economy, the environment, and all members of our community. And as we celebrate our 15th anniversary in the middle of this year, we don't take credit for growing the economic impact of the San Diego clean tech industry to over $9 billion, but we are the center of gravity and the convener of public-private partnerships that have played a key role in facilitating this growth. And just to put things in perspective, the 38,000 plus clean tech jobs just across the San Diego region represent almost as many jobs as are left in the entire United States coal industry. Another reason that California is a great place to launch a clean tech business is that back in 2006, California passed Assembly Bill 32. That was the first law in the United States that mandated greenhouse gas reduction to address climate change. And since that time, you can see that additional legislation has been passed that mandates the adoption of renewable energy with a goal of 100% renewables by 2045, energy efficiency, including zero net energy requirements for residential and commercial buildings, energy storage that provides resiliency to a renewables dominated grid, and transportation electrification, where Governor Newsom's 2020 executive order prohibits the sale of internal combustion engines by 2035. And even with the most stringent climate and clean energy codes and policies in the United States, pre-COVID-19, California's fifth largest economy in the world had achieved an average 3.8% GDP growth for the previous 5 years, clearly demonstrating that green growth is not only possible, but it is profitable. And so I'd now like to introduce our second team presenter, Joshua Carter, and his hybrid team, representing both UC San Diego and Cal Poly Pomona. And they'll be presenting on Nuclei Ventures small modular reactors.
Thank you, Marty. Hello, everyone. We are Nuclei Ventures. Today, we are introducing integral molten salt small modular reactors for commercialization of energy. Next. Our team consists of Dr. Brisha, Director of Metrology and Quality Control, Senestin, as our technical commercialization mentor, Dr. Labrim, Professor and former researcher at the French Atomic Energy Commission, as a technical mentor, Shayman Nasir, civil engineering student at Cal Poly Pomona, and me, Josh Carter, economics student at UCSD. Next. Today, our world has an energy crisis, and the Biden administration has the vision to achieve clean energy by 2035 and net zero commission by 2050. Our IMSR reactor helps achieve the 2021 infrastructure bill goals by providing heat, desalination, hydrogen as a second source of energy, energy to remote communities, replacement of conventional coal-fired power, and high-temperature steam for heavy industry. This technology can be easily implemented into the existing renewable energy infrastructure, providing a necessary layer of baseload energy. Shayman will now describe our technology. Next.
Hello, we have chosen a 400 megawatt SMR reactor technology that uses single fluid burner. All major components are housed in a single integrated core that's designed to be replaced every 7 years. It uses thorium, which is 3 times more abundant than uranium, or low enriched uranium blended with lithium sodium fluoride. This avoids extra costs and the time issues of relicensing uranium reactors. The reactor has a 56-year design life compared to MMRs, which have less than 20 years. Next. Advantages: we have small footprint compared to solar, wind, or conventional nuclear, as well eliminating the need for offsite emergency response, equipped with autonomous safety bonding shutdown system. Fuel refill costs are minimal, designed for shorter construction completion period and trunk transport. Nuclear has one of the lowest carbon producing footprints of all energies. One of the challenges is licensing. That's why we have established a licensing strategy we'll be talking about later on. And we'll be consulting with Cannabis Energy Group that has extensive experience in SMR and MMR's licensing. Next.
The US Department of Energy estimates that domestic output from SMRs for the US could be as high as 50 gigawatts by 2035. Our levelized cost of electricity is competitively priced with renewables and fossil fuels at 55 megawatts per hour, $55 per hour. We expect to price competitive PPA contracts at $60 per megawatt hour. Our overnight costs per reactor, including construction costs, operating and maintenance costs, and decommission costs, are estimated at $524 million. Economies of scale will bring this price down as more reactors are produced. At a 50% operating capacity, we expect annual sales of $105 million per year per reactor. Next. The economic impact of this project will add tens of thousands of high-paying American jobs to the market. The global SMR market is expected to be valued at $1 trillion by 2035. The example below highlights annual sales, annual state and federal tax revenues exceeding $13 million for each SMR reactor. Next. Our sales strategy includes the following: identifying our primary target customers as mining operations, heat industry, and remote communities. Partnering with terrestrial energy to start construction and deployment of our first reactor. Sign competitive PPAs with our customers. Expand operations into a vertically integrated firm that manufactures and delivers efficient and safe energy systems. Partner with emerging MMR, SMR manufacturers that have promising technologies. Next.
One of the advantages of this technology, it already has an RRC application review that starts back in October 2019. By 2022, we hope to finalize our management team and add nuclear engineers as well an SFO and establish a partnership with terrestrial energy to commercialize their technology. At the end of 2022, we'll establish a partnership with the Oregon National Lab to work on licensing as well to perfect this technology. 2023, we'll obtain site licensing for reactor placement, and 2026 we'll have our first reactor deployment. 2030, our goal is to move to a vertically integrated firm. Next.
We have a competitive advantage amongst our competitors that includes lower capital costs, the ability to produce hydrogen as a byproduct of our reactor operation, heat temperatures above 800 degrees Celsius that result in lower overall pressure load and more efficient fuel burning. Next.
We have established a safety and licensing roadmap, and we'll be working with the DOE Office of Nuclear Energy that already have an SMR licensing technical support program that focus on the improvement of advanced and safety and operation and security features, and also toward cost sharing effort that will excel the certification, licensing, and the siting of domestic advanced SMRs design and reduce economic and technological regulatory barriers to this deployment. And that's it.
Thank you.
Thank you.
All right, and thank you, Nuclei Ventures team. By way of background, in the 2016 timeframe, the California Energy Commission and the California Public Utilities Commission completed an analysis wherein they extrapolated California's adoption rates of energy efficiency, renewables, and electric vehicles. And despite California's national leadership in these areas, where in fact 50% of the 2 million EVs on the roads in the United States today are in California, they still identified a significant gap to the achievement of the state's 2030 greenhouse gas targets. It was clear that a business as usual approach was not going to work. So they allocated $60 million in EPIC grant funding and tendered 3 solicitations that created the state's energy entrepreneurial ecosystem. The 3 key objectives of this entrepreneurial ecosystem are climate change mitigation, green, clean energy growth, and climate equity, making sure that the underserved communities across the state that are most negatively impacted by air pollution and climate change impacts are included in all of these solutions. And the CEC's primary market focus for this clean energy economy includes building decarbonization, grid decarbonization, resiliency and safety, the agricultural and industrial sectors, and clean transportation. And not surprisingly, these priorities are right in sync with the Department of Energy. So now it's my pleasure to introduce our third presenting team, the CSUB runners from CSU Bakersfield, led by Sammy Cortez, lead presenter, and they're going to be presenting on gas in the ground, carbon dioxide sequestration in California.
All right, can you hear me clearly? I assume that's yes. All right, so hello everybody.
Yes.
My name is Sammy Cortez, and I'm representing gas in the ground sequestration in California. Slide. So the technology that we're evaluating has to do with carbon sequestration and current technology used to, sequester carbon dioxide. So the main focus, or rather the focus of the market at the moment is using existing pipelines. Now, this is because it's a lot cheaper to use, instead of actually creating newer pipelines. But at the same time, though, because a lot of them are made of carbon steel, it makes it, they become more exposed to corrosion. So as a result, the technology that we're evaluating has to do with any sort of technology, or of any coating that could be used to input in the inside of those coatings, or rather on the inside of those pipes, so that it becomes strengthened and more likely to not corrode. And so the additional technology of note has to do with pigs. So for those of you who don't know what a pig is, what you just do is you take like a baby pig. All right, you take a baby pig, little piglet, oil it up in a bunch of oil, you smush it down a pipe, and it cleans the inside of the pipe. That's not what a pig is used for. I'm actually talking about pipeline inspection gauges. So that's PIG, pig. So that's actually currently used to clean the inside of pipes. I was as disappointed as you are. Slide. Market assessment. So the big players in this market would also be, or rather it would be major oil companies. So oil companies like SoCalGas, ExxonMobil, Chevron, Era, they're all going to be huge players in terms of being consumers. Now, and in terms of competitors, because this technology is pretty, I'll admit it, it's pretty difficult to produce. So at the moment, it's kind of like a very vacant, nascent market at the moment. But one of the major markets, or excuse me, one of the major competitors at the moment would be Baker Hughes, which is the largest industrial pipeline company in the world at the moment, headquartered in Texas. Yeah, next slide. All right, so economic feasibility assessment. So the price range we propose for a mile of this coating would be $50,000 to $100,000. Now, again, that's conceding a lot of specifics. A lot of this would be depending on the region it's going to be implemented in. It could be depending on the type of coating used. It could be depending on what type of technology is used in addition to the coating. But at the moment, though, we could safely say that as a result of economies of scale, that if we could mass produce this to different carbon sequestration facilities, that this could generate tens of billions of dollars. By that, I mean that not one specific carbon sequestration facility would actually generate billions of dollars because they would pay for the coating. Instead, what it actually means is when you add up all of the facilities that are using this coating, that would generate billions of dollars. And considering that a lot of carbon sequestration facilities are already interested in using existing pipelines, you can pretty much guess the amount of money that can generate. Next slide. Potential impact. All right. So I'm from Kern County, and Kern County is probably known for having one of the worst, consistently some of the worst air quality in the entire United States, up there with Los Angeles, so on and so forth. And, because of that, at the same time, a lot of the residents that live here are from communities of color. So as a result, a lot of them are also facing common issues regarding healthcare, education, so on and so forth. So therefore, the role that our technology would be is to encourage the creation of more carbon sequestration facilities, which would minimize the impact of climate change, but also disproportionately benefit those persons of colors. Next slide. Overall business plan. Okay, awesome. So when I was thinking about, or rather when our team was thinking about our overall business plan, we were thinking about the full range of people that would be involved. Not just like huge companies like CalGEM, Era, Chevron, but also even smaller figures within our university. So for example, we can even be talking about the NSM&E faculty at our engineering department. So for example, here we have a few names: engineering, Professor of Engineering, Dr. Luis Cabrales, geology, Laosha Song. And at the same time, in terms of what our overall business plan is, our success is defined as a pilot project involving testing of the metallurgy with CSUP NSM&E faculty, local experts, and a white paper with meaningful participation from all players. And of course, we're also teaming up with the one of the people in our network, Cornerstone Engineering, which is a consultant firm for engineering products. I believe that's it.
All right, thank you, Sammy, and thank you to the CSUB runners team. Moving forward, at the heart of the CEC's entrepreneurial ecosystem are 4 innovation cluster organizations that span the state. Starting in the south is our Southern California Energy Innovation Network that we call the SEAN. We provide support, service, and referrals to entrepreneurs across the San Diego, Imperial, Riverside, and San Bernardino counties. Just north of us, the LA Cleantech Incubator serves startups across LA, Orange, Ventura, and Santa Barbara counties. Lacey was founded as a nonprofit economic development incubator by the City of Los Angeles and the LA Department of Water and Power. In addition to their CEC-sponsored Innovators Program, they also have a 2-year incubation program. The Blue Tech Valley Incubator is run by Cal State Fresno and is closely integrated with the work of their Water, Energy, and Technology Center. They have responsibility for the 39 counties across California's Central Valley agricultural belt. And as such, they have particular expertise and focus on the energy, water, food nexus in the agricultural and food processing industries. They also operate the Valley Ventures Accelerator. And completing the statewide startup support network is the Activate Incubator that is run by Cyclotron Road and covers the remaining counties in the Bay Area and Northern California. This particular incubator has a primary focus on what we refer to as hard tech, actual breakthrough products and systems rather than software as a service business models. I'll be providing you contact information for these 4 innovation clusters later in my presentation. But it's now my pleasure to introduce Yuan-Jun Lee, whose team from Stanford University will be presenting on GOS energy converting oil wells into clean energy storage.
Thanks for the introduction. So I lead a team of Stanford PhDs and MBA students designing a long duration energy storage solution through repurposing brownfield assets. Slide. We're in the historical moment of transitioning from fossil fuels to renewable energy. But for this to be successful, we need long duration energy storage. Solar and wind power are critical to the energy transition, but unreliable without storage. Unfortunately, there are no clear solutions to long duration energy storage today. On the other hand, the declining oil and gas industry is leaving tens of thousands of depleted oil wells, which are leaking methane and causing other environmental hazards. In addition, there are 10 million oil and gas employees in the United States. As an engineer at Chevron, I saw that when oil leaves California, communities are left in distress. There is an opportunity to preserve jobs and communities while solving environmental liabilities by repurposing these unused wells. Slide. GeoS captures both opportunities. Slide. Here we present the geobattery technology to redefine the oil field. First, we use renewable energy to transform water into steam. Steam is then pumped into the depleted reservoirs and stored there until optimum extraction time. When the energy demand is high, we can convert steam into electricity through a turbine and send energy to the grid. In short, we are repurposing idle brownfield liabilities into critical green energy assets. Next, my colleague Leah Edwards is going to introduce market and opportunities of this technology. Slide.
We know that long-duration energy storage is a huge opportunity. According to a report published by McKinsey, the global long-duration energy storage market could be more than $1 trillion by 2040 and needs to scale up 400 times from where it is today. There is a lot of potential upside for successful technologies in this space. Slide. A key differentiator of our technology is that it enables us to breathe new life into brownfield assets. Across the United States, there are nearly 2.6 million onshore oil wells. And currently within California, there are 35,000 idle oil wells that are not actively producing. Instead of oil companies or the government spending billions of dollars to plug these wells, GOS would enable companies to turn these liabilities into green energy assets. We've mapped the location of these wells versus the demand of the grid in California and have identified certain regions where there's a shortfall of dependable capacity generation and there are idle oil wells nearby. Utilities are willing to pay a premium for storage in these regions, which presents an exciting opportunity for GOS. Slide. GOS's business model will provide 4 key sources of value, plus many co-benefits. First, we'll be able to increase the capacity of the grid by selling long-duration energy storage to utilities, CCAs, and corporates at around $50 to $150 per kilowatt year. Second, we'll be able to provide energy arbitrage services to the California Independent System Operator, CAISO, for $30 to $70 per kilowatt year. Third, we'll be able to help oil companies defer the $40,000 to $150,000 it costs to remediate a single oil well. And fourth, GOS will preserve jobs in the oil and gas industry and protect the resilience of the communities in these regions. We also provide environmental benefits by making brownfield assets green. Slide. We've evaluated several different business models and believe there's the greatest potential in acting as a service provider for oil and gas companies. This business model requires minimal upfront costs, it's easy to implement a pilot, and it reduces our liability as the assets would continue to be operated by the oil and gas companies. Slide. There are a lot of players in the long-duration energy storage space, but there are no clear winners, and GOS has a number of competitive advantages. Our biggest competitive advantage is the ability to store energy for long periods of time, up to about 1 month. For reference, lithium-ion batteries can only store energy for up to 8 hours. GOS's technology is also safer than that of some competitors, such as utility-scale batteries, and has a longer lifespan. In addition, unlike most competitors, GOS is repurposing existing brownfield assets, which will help preserve jobs and communities in that industry. Slide. If we want to have reliable, long-duration energy storage by 2040, we need to be acting now. GOS has the potential to provide long-duration energy storage at a reasonable cost using existing technologies in a way that leverages existing infrastructure and preserves jobs and communities in the oil and gas industry. In short, we believe that GOS is the future of seasonal energy storage. Thank you.
All right, thank you, Team GOS Energy. Now I'd like to take a moment to share some insight into how the 4 innovation clusters provide services to support startups in accelerating their commercial traction. And I'll use our Scene Incubator as the example. I have a program director, Zach Dobbin, and and a program manager, Natalie Toon, who work with me to lead the outreach and to identify new startups, conduct the entrepreneur intake sessions, and to screen applicants for their eligibility and fit. We also prepare customized service plans and facilitate connections to both public grant and private capital sources. We have subcontract agreements with all of the entities that you see on this slide, including the engineering schools and business schools at UCSD, SDSU, UC Riverside, University of San Diego, and Cal State San Marcos, as well as the Center for Sustainable Energy and Connect. We facilitate meetings with subject matter experts and engagements with student teams for support in addressing both technical and business needs at no cost to our entrepreneurs. But beyond that, what I like to refer to as our secret sauce is our technical advisory committee. With Cleantech San Diego being a cleantech industry trade association, we have over 120 members spanning the public and private sectors, including companies like SDG&E, EDF Renewables, Black & Veatch, Itron, and Cisco, as well as public agencies, including the cities of San Diego, Chula Vista, Carlsbad, the Port of San Diego, and San Diego International Airport. These TAC members are available for conducting customer discovery, to host pilot evaluations, and in some cases, even invest in our startups. The other 3 cluster incubators across the state operate similarly, leveraging relationships with the university and industry partners across their geographies. For my next few segues, I'd like to track the typical progress of a startup from conception to commercialization. And in the startup world, we typically classify the stage of a startup in terms of the state of their technology development, which we track by technology readiness level, TRL, on the horizontal axis, and their state of fundraising, which is captured on the vertical axis. From the point of ideation to laboratory proof of concept is typically considered to be TRLs 1 through 4. At the point where you have a fully integrated minimum viable product that is suitable for field testing, we consider that to be TRL 5 and 6. And TRL 7 through 9 are typically the refinement of commercial product specifications and manufacturing scale-up for cost optimization. But the other thing that's well known about the startup lifecycle is that there are almost always speed bumps along the way, which are commonly referred to as the potential valleys of death. In the early stage, startups typically fund their development with grant awards from the co-founders' own funds and reaching out to friends and family. But more often than not, those funds can run dry before you get to full proof of concept. Well, I'm happy to report that the CEC has proactively created a new funding opportunity that can be used to address this first technology valley of death, which I'll tell you about when I return after our next presenter. And so now it's our 5th presenting team, another joint collegiate venture with team members from both Stanford University and Carnegie Mellon. Michael Bendock will be their lead presenter telling us about FUNDUSOL.
Thank you, Marty. Now more than ever, it is crucial to address food and energy in the context of our climate crisis. Slide, please. Over the past decade, 120,000 family farms who disproportionately belong to communities of color have lost their livelihoods due to competition from larger farms. And in the next decade, thousands more will face the same fate because of drought, surging electricity prices, and degrading soil quality. Slide, please. Meanwhile, the solar industry is struggling to meet the pressing need to decarbonize because even when land is cheap enough to build solar, high temperatures degrade solar performance and profit margins, and predatory developers implode projects before they're even built. Slide, please. This is why we came together to create FUNDUSOL, to address the issues devastating small farms and face the challenges meeting the solar industry through agrivoltaics. Slide, please.
So to put it simply, agrivoltaics is putting solar panels on top of crops. In addition to using land significantly more efficiently, both the panels and the crops reap mutual benefits under this scheme. Slide, please. This is because the shade from the panels cools the area underneath them, creating a microclimate close to the ground with ideal growth conditions for shade-tolerant crops like the ones we'll be focusing on. In addition, the evapotranspiration from those crops cools the solar panels as well, which improves their efficiency. Finally, the increased moisture retention underneath the panels means that farmers have to spend significantly less money on irrigation costs. Slide, please. And this isn't a brand new idea. Here's some university research data to back it up. We see that in addition to using land much more efficiently, crop yield can up to double under agrivoltaics, in addition to significantly improving solar output and water usage. Slide, please.
Despite all these benefits, there are exactly 0 companies marketing agrivoltaics in America. The competitive landscape is barren. Slide, please. There are 4 main reasons for this, primarily a lack of research into generalized agrivoltaic systems. Most of the research going on in agrivoltaics is on university campuses done privately on a single crop on a single farm, simply does not generalize to farms all over the world. Additionally, the cost and inaccessibility of solar technology, along with low awareness of agrivoltaics, pose additional barriers to entry. Slide, please. Our solution is multifaceted. We've created an input process output model that can create a final agrivoltaic plan for farmers. It includes a financial model and a plan to profit. And in the near future, we plan on immediately partnering with drone inspection companies and solar maintenance companies to make the transition to solar easier for small farmers. Slide, please.
Here's a basic input process output model of our algorithm. In short, it takes any farm in the world and produces 3 key outputs. Starting with the left branch, we use a variety of metrics, including real-time GPS data, and plug that into our panel rotation, backtracking, and shadowing functions. This allows us to make informed decisions about the system's solar tracking behavior. On the right side, we have our Carnegie Ames Stanford biomass model, which takes in inputs like climate, irradiance, and soil data and predicts crop yield. And lastly, in the middle, our financial model works to minimize the cost to farmers. Slide, please. Bringing all these sophisticated models together, we can deliver agrivoltaics to US farmers in a cheap and optimized way. Slide, please. To test this, we conducted a case study on the Stanford farm. Let's focus on the image. What you're looking at is an agrivoltaic scheme containing east-west single-axis tracking modules. Using our algorithm, we found that this produces a completely homogeneous monthly light integral, as seen in the heat map in yellow, which is perfect for shade-tolerant crops. So while utility scale solar typically uses south-facing panels, our computational approach revealed that the optimal configuration for agrivoltaics was east-west tracking. Slide, please.
And we also built a financial model to uniquely meet the budgets of each and every one of our clients. On the left, we provide them with enough electricity to power their farms at a significantly reduced price. On the right, we structure a PPA agreement, and in the middle, we completely pay for the system using these profits by year 7. Our case study of the Stanford farm found a net present value of the profits to be $220,000 over the system lifetime. Slide, please.
Here at the bottom, we can see that our serviceable obtainable market of small to medium-sized farms growing appropriate crops is almost 80,000, which gives us a massive potential market. But most immediately, we want to focus on the California lettuce industry. Lettuce, because it's a highly shade-tolerant crop with a very high price per acre that's shown excellent results under agrivoltaic research. And California, not only because it's close to home for most of us, but also because perennial drought in the state means that irrigation costs pose an unpredictable financial burden for small farmers. After success there, we hope to expand to more crops in more states. And after that, we hope to develop novel solar technologies specifically fitted to agrivoltaics, like LED growth lights fitted on the undersides of solar panels or height adjustable solar trackers that we hope will further improve the efficiency of our algorithm and methods. Slide, please.
My name is Michael Bendock.
My name is Luca Borletti.
I'm Esteban Herrera Vendrell.
And I'm Pete Westbrook.
And we are FUNDUSOL.
Thank you, FUNDUSOL team. And now back to the startup life cycle. So recognizing this common early stage valley of death as part of the original CEC entrepreneurial ecosystem grants, they allocated $25 million to fund the CalSeed program to address this funding gap. The CalSeed grants are offered annually in 2 phases. Typically, early in the year, they announce a solicitation for the phase 1 concept awards. These are non-dilutive grants of $150,000 that can be used to complete your proof of concept. Usually, they award around 16 of these grants equally distributed across the 4 state innovation cluster geographies. Then, during the 4th quarter of the year, the 16 concept award winners compete for 5 or 6 $450,000 prototype awards in their own business plan competition. So you're already getting a head start in preparing for this grant solicitation. Now, once you've successfully made it through proof of concept, it's then time to complete your minimum viable product and get some potential customers to test it. So the next speed bump that you encounter is that most industrial customers are not willing to expend their resources to test non-commercial products unless they've been demonstrated to be safe and to truly deliver the value proposition claims. And I'll tell you what the CEC has come up with to address this potential commercialization valley of death in my next installment. But for now, I'm going to introduce our next presenting team called EcoBreeze. We use physics to keep you cool. The team's from University of San Diego, and Kylie Rios is their lead presenter.
Thank you, Marty. Hello, everyone, and thank you for having us today. My name is Kylie Rios, and I am joined here today by Megan Piptone, Mary Hennick, and Colton Landish. We are presenting on behalf of our team, EcoBreeze. We are a team of 6 engineers and 1 business liaison from the University of San Diego. Today, we will begin with an overview of our technology. Next slide, please.
Thank you, Kylie. EcoBreeze is a cooling system that utilizes thermoacoustic technology in an innovative way to greatly decrease both the environmental and monetary cost of comfort. Thermoacoustics utilizes sound waves to manipulate properties such as pressure, temperature, and density of a specific medium. By playing sound at the resonant frequency of the tube, we can create a region of high pressure at the nodes of the standing waves and a region of low pressure at the antinode. These high and low pressure zones directly affect the temperature of the tube. We then store this temperature differential in a stack in order to remove heat from the surrounding air. Currently, the industry has experienced the success of thermoacoustic engines, refrigerators, and freezers. What the industry has not yet seen is the commercialization of thermoacoustic cooling systems. This is our product. Next slide, please.
We are creating a thermoacoustic cooling system to be sold to manufacturers such as Honeywell, GE, and LG. Manufacturers will want to use our system as a component because it will be more efficient and lower cost than a standard AC unit. The modern cooling market is crowded with conventional air conditioning units, which are known to be expensive, and many people cannot afford to continuously run them in their living spaces. In terms of the end user, we are mainly aiming at people in underserved areas. Although we are not selling directly to the end user, we do still have control in creating something that is environmentally friendly and of low cost. Next slide, please. Customers currently use evaporative coolers, which have been proven to be inefficient and quickly add a lot of humidity to the surrounding air. Traditional air conditioning units are expensive to install and run, and fans are simply recirculating warm air. Technology users in adjacent markets include NASA's thermoacoustic refrigeration system for their space shuttle and Ben & Jerry's thermoacoustic ice cream freezer. We're the first to implement thermoacoustics in a cooling system that will be more efficient, have no moving parts, and is cheaper to produce than other cooling systems on the market. Next slide, please.
Thanks, Mary. We envision EcoBreeze operating as an OEM. Using a business-to-business model, our customers will be existing HVAC manufacturers who will use our license to sell to the end user. The cost to the end user will greatly vary by size and power of the unit. Capital cost of our system, as well as operating costs, will be determined by the expenses incurred by our manufacturers to produce and how they decide to implement our cooling system in their products. Our technology consists of no moving parts, yielding extremely low maintainability results. With virtually no service requirements, The only cost to the end user after their initial investment is in their utility cost, which will also be lower than an AC unit. Initially, we expect it will cost $25,000 to get a demonstrable prototype, and this estimate includes cost of materials, equipment, as well as licensing fees. We have begun a prototype using over $15,000 of seed funding that we have received from winning our university's business concept competition. As engineering students, we are working for free and have access to state-of-the-art prototyping equipment in the Bellenic laboratories. Next slide, please.
We see eco-friendly products as the future, and EcoBreeze has the potential to make a world-scale impact because 1/3 of Americans do not have AC. Customers will benefit from EcoBreeze's cooling system by having affordable and effective cooling. EcoBreeze's thermoacoustic cooling technology will especially help people who cannot afford a fixed centralized AC unit. One of our main goals is to help people and the planet. We believe in the ability of new generations to progress sustainability trends in the cooling industry. This is why we are committed to only operating and working with ethical and sustainable suppliers. Shareholders will benefit by having invested in cutting-edge, eco-friendly thermoacoustic cooling technology. Our solution will be at a relatively low cost to the environment, as it is free of greenhouse gas emissions. As a team of engineers, we are dedicated to using physics to create a cheaper way for our customers to keep cool. Next slide, please.
EcoBreeze will lead the cooling market in more sustainable, emissions-free future. We will consider our company's success when we are able to say we are the top company in sustainable cooling technology. As far as metrics go, success for EcoBreeze will be defined by even cash flow by the 3rd year of our company's start. This will entail optimizing our proof of concept and building a reference design in order to land contracts with successful HVAC manufacturers. This technology has the potential to be scaled up and integrated into larger buildings, such as schools and office buildings, in order to serve the greatest portion of users. We are currently in the rapid prototyping phase and are now looking for further seed funding to commercialize our unit. Next slide, please.
Thank you all for listening to us today. And remember, EcoBreeze, we use physics to keep you cool.
Thank you so much, USD EcoBreeze team. As we now return to our journey up the startup lifecycle, I'd now like to introduce you to the Cal Testbed Voucher Program that has been created to address this next potential commercialization valley of death. The Cal Testbed Program provides clean energy innovators access to prototype testing through vouchers worth up to $300,000 in services at one of 60+ world-class test beds located at 9 UC campuses and Lawrence Berkeley National Labs. This testing helps entrepreneurs by de-risking their innovation and demonstrating that they are safe and deliver the benefits claimed, which eliminates the 3 key barriers to securing customers' field deployments. Applicants must be based in California and have a ready-to-test hardware or integrated technology that fits into one of the eligible energy technology categories. And of course, be aligned with the EPIC funding priorities of greater reliability, lower cost, and increased safety for California ratepayers. You do not have to be a member of one of the CEC cluster incubators to participate in the Cal Testbed Voucher Program. So if you're going to have your MVP ready by the middle of this year, then keep an eye out for the 2022 Cal Testbed solicitation in the late May and June timeframe. And now it's my pleasure to introduce our next team, another collegiate joint venture, this time between UC Berkeley and the University of Michigan at Ann Arbor. Their lead presenter, William Roberts, is going to introduce us to the MANTA underwater kite system.
Thank you, appreciate it. My name is Will. I'm here to introduce you MANTA, scalable, clean, simple hydrokinetic energy solution. Next slide. So just quickly overview of the technology. I want you to just think of when you're flying a kite, the lift force you get from the wind. It's the same principle, just like when a manta ray is swimming in the ocean. It's the hydrodynamic lift force created by the underwater current to move the kite. And it's this motion of the kite that harvests energy into the power takeoff mechanism. The onboard energy generation allows for greater energy efficiency, which can be transported in a variety of ways. Next slide. There's a ton of technological advantages to a kite as opposed to a turbine, which is the most used hydrokinetic energy resource nowadays. Designed for 20 kilowatts of energy per kite, and that can be scaled up to 50 kilowatts depending on the kite size. You don't need a rigid mooring system. You don't need a giant tower. It's really just a simple system. And the biggest thing is that with the simple system, lower pressure drop, safer for animals, which is a huge part of this, just safer overall for the environment. Next slide. Market assessment. So when everyone thinks of hydrokinetic energy, everyone's really looking at the big numbers, resource potential, technical potential. And those numbers are great. I think in the United States alone, there's 2,300 terawatt hours of technical potential energy available. But really, I just want you to think about the process of it, because we're not going to solve this with one giant turbine. It's going to take baby steps. It's just like, think of a really good basketball player from Kansas. He's not going to be able to be thrown into the NBA immediately. It's going to take time to develop this, just like it will with any hydrokinetic resource. So the goal initially should be to reduce the dependency on diesel generators for remote and isolated villages where import diesel is extremely high, which we'll go over later, and the ability to accommodate the desire to maintain self-sufficiency with energy production. There's also a ton of other applications. Based on predictable power, you can use desalination, disaster relief, ocean cleanup, ocean pollution cleanup, a ton of other stuff. Next slide. Ideal client areas with levelized cost of energies of over 50 cents per kilowatt hour, and obviously near a river or tidal resource with water speeds over 1 knot, which is about half a meter per second, which really isn't that fast. The ability to operate in lower currents significantly expands the potential resource area. A relevant market for what I would say would focus on currently would be Alaska and Canada, where there's an estimated almost 400 villages capable of utilizing MANTA, just because so many of these villages are based near water and it costs an arm and a leg to fly in the diesel. And in a future vision, it can really go anywhere. Think of the US island systems, think of India, Africa, anywhere with tidal flow. Next slide. So now the economic feasibility analysis. The levelized cost of energy for MANTA can be estimated at 10 cents. That's extremely good compared to the current range in Alaska, is anywhere from 14 cents to 90 cents. It's important to note the national average is 12 cents. So it's costing a ton of money to get the energy to these remote areas. Retail fuel costs anywhere from $5 to $10 a gallon in Alaska to import in. And then another thing you got to realize, the major urban utilities can sell this power for a lot more than what the rural utilities can produce it at. And a lot of power savings programs, a lot of these places aren't eligible for it. Next slide. The potential impact, this is where it gets really cool, because a lot of these isolated communities, they have no infrastructure. We're not talking about like they have a movie theater or even a restaurant. They have a school, a post office, and a couple houses. The picture to the bottom right is one of the more developed communities in Alaska, but even then you can see the unique setup to harness hydro with little infrastructure. So in order to promote energy self-resiliency and create a positive influx in the economy, you could establish a business which allows these communities to accommodate MANTA systems, which will in turn, next slide, the potential impact is just basically create more opportunities for the local villagers. Now, once you derive this electricity, it doesn't stop there. You have to think bigger. You have to think of this as a vision. It's not just a vision to get new electricity. It's a vision that you can self-sustain. You can reach your dreams. Say you want to have a cupcake business in the middle of Alaska. You can't do that if you're paying 80% of your bills to fly in the diesel or to pay for that energy. We can allow local villagers to harvest the natural resources easier with this electricity. Obviously, the money's being spent in easier ways. Build a stronger economic base. So that's what we talked about. If you want to have that cupcake business we're talking about, you can put more money into your dreams and passions instead of paying for the diesel. And also a big part of this is allowing native communities, such as Indian tribes, to maintain their cultures and traditions based on just using energy from water. Next slide. The business plan, I didn't want to get too into the details about it because there's a ton of opportunities for this, whether the community is being sold the MANTA power or they're being sold a supply box, which they say, oh, here's an instruction set. Here's how you do this with MANTA supervision. But the necessary things that would have to go on for this is obviously a more efficient supply chain system where you're not flying in the diesel, obviously, you're flying in a MANTA supply box. A simple and efficient energy storage solution. Obviously, we've heard a ton about that throughout today. There's a lot coming down the pipeline with that, but battery storage generators for short term to replace the diesel, or just setting up microgrid solutions. Vocational training programs so that these villages can learn how to use MANTA. I mean, you can create so many jobs from just oversight maintenance. A local utility place can help contribute to this. Then introducing legislation for more extensive power savings programs for tax incentives for the rural regions that use hydrokinetic. And again, it's a vision. It's not really as much as a business plan. It's a vision that you can create clean energy on your own. And that's like really going to be the only way that we can reach these goals. It's just starting small, not trying to take too big a bite of the apple. If that makes sense. But yeah, thank you. And that's all I got for you.
All right. Thank you, William. And thank you, Team MANTA. We return to our startup lifecycle curve. So now, once you've launched your field pilots that turn into your initial commercial sales, and you need to transition from small scale piecemeal production to more automated manufacturing to reduce costs and keep up with the increasing demand, some of the CEC's core grant programs can still offer non-dilutive funding to support initial business scaling. As you heard in Judge Eric Stokes' introduction, the CEC R&D division awards over $170 million in new funding each year for cutting-edge innovations. These are typically tendered as either GFOs, grant funding opportunities, or EPIC grants. These grants fund diverse projects across all 5 of those priority decarbonization markets that I showed on one of my earlier slides. However, there are 2 particular grants nicknamed the Bridge and Ramp grants that are offered on an annual basis. As the acronym Bridge would suggest, these CEC Bridge grants provide additional non-dilutive funding to enable some of the most promising and perhaps most challenging energy technologies to maintain continuity of funding between CEC, DOE, and other federal grants. And the RAMP acronym stands for Realizing Accelerated Manufacturing and Production. RAMP grants, which typically range from $1 to $3 million, provide financial assistance to help energy entrepreneurs successfully advance their emerging best-of-class innovative technology to the low-rate initial production stage. So as you can see, the CEC has come up with these creative funding offerings at every step along the way of the startup life cycle. In addition to all the grant funding opportunities that are offered by the CEC, there are numerous other local, state, and federal grants, competitions, and accelerators that all 4 innovation clusters can steer you to. For early stage startups like those presenting today, the San Diego Angel Conference is a 7-month cycle that connects angel investors and entrepreneurs. There's an e-track that provides mentorship in developing your pitch deck, and it culminates with a pitch competition amongst the finalists, with the winner securing a $200,000 investment. And this virtual program is open to startups from anywhere. I obviously don't have time to speak to all of these programs, but I'd be remiss if I didn't point out that the Department of Energy and NREL, our hosts for this event, offer a number of fantastic programs, 3 of which I've highlighted on this slide. In fact, the HeroX portal that you used for this competition also provides access to the DOE's American-Made Network. This ongoing series of challenges offers opportunities for entrepreneurs to win cash and voucher prizes while helping to solve some of the toughest challenges along this clean energy transition. And NREL's partnerships with Shell on the Game Changer program and Wells Fargo on the IN² Innovation Incubator are 2 outstanding programs offering technical and business mentoring for later stage startups. To participate in one of these programs, you must be referred by one of NREL's connector partners that Cleantech San Diego and the other innovation clusters all are. My final takeaway point from this slide is that over my 5 years leading the Scene Incubator and observing the successful startups across the innovation ecosystem is that the ones that have secured the biggest investment in success took advantage of several of these programs, not relying on just one. It's now time for me to introduce our 8th team that comes from San Diego State University, and lead presenter Joshua O'Connell is going to tell you about Volastore.
Hello, everyone. My name is Joshua, and I have had the fantastic experience of working with Arash and Reza under the guidance of Dr. Minshadi to implement our new company called Volastore, Battery as a Service. Living in California, we are on the precipice of the renewable energy innovation curve. However, what's becoming more apparent as time goes on is that these renewable energy systems aren't being managed or incentivized for the prosumers to keep up with the modernization of our grid. For those who do not know, a prosumer are our target customer base. Consumers consume electricity, prosumers produce electricity. Next slide, please. What is Volastore and what can it do for me? Volastore is a battery aggregator-based energy management system that provides battery as a service to subscribers. Prosumers can take advantage of our BAS subscription by having our rechargeable battery leased to them at a discounted price and are also able to participate in the energy market with virtual bidding. Our mission is not to compete with utility providers, but rather to serve as a demand response for them. We accomplish this massive feat by targeting all prosumers in residential, housing, and commercial buildings. By creating a carbon-aware smart energy asset management with BAS subscription, we are able to create a virtual power plant platform for our subscribers. Next slide, please. Now, what does the electricity market look like? The wholesale electricity market is broken into 2 sectors. You have the real-time and day-ahead market, which is where the virtual bidding takes place. Volastore's proprietary software analyzes the 2 markets using artificial intelligence that merges the 2 markets to form a convergence bidding experience for profit maximization. Now we have an untapped market and it's up for grabs. We have 1.3 solar customers and 2.5 million potential customers that exist in California. An approximate amount of 40 gigawatts of electricity produced with only 400 megawatts being traded by virtual bidders. The bottom right figure displays the logic that calculates the convergence bidding process to generate revenue. Next slide, please. Volastore's business model is to make money beyond the customer payment, where we aggregate our batteries within the power network to participate in the electricity market. We are able to provide a competitive advantage by sharing the profit that we are making in the electricity market with prosumers. Therefore, we have multiple revenue streams from subscription and also market participation. Now, one should note that batteries for the power grid can be second life batteries, such as used EV batteries, electric vehicles, which are much cheaper than brand new batteries in the first place. And we also have battery health optimization within our logic. Next slide, please. Volastore's 3 key principles. The first one is dispatchable sustainability. Currently, the nature of renewables are such that smart inverters are currently being used by utilities to curtail the renewable energy production made by the prosumers. Volastore's mission is to increase the dispatchability by adding our affordable second life batteries leased to our subscribers, along with our energy management system to add to the robustness to the grid while incentivizing sustainable resources. Our second key principle is investable inclusion. The aggregation of our customer pool and proprietary energy management system into the electricity market will be accomplished by making participation in the the renewable energy less intimidating and more affordable to those wishing to become prosumers. The second life batteries leased to subscribers, maximize profits, smart investing tools, and ease of use make an inclusive investment opportunity for those all wishing to invest in Volastore. Our third key principle is reliable resilience. With our battery as a service network, dispatchable resources along the smart energy management system, Volastore is able to coordinate with utilities during events such as public safety power shutoffs. Our system is able to coordinate with utilities, which gives them a chance for continuity of power to their consumers during one of those events. Our reliable resilience is just one aspect of what Volastor has to offer to the modernization of the grid. Thank you very much.
Thank you, Joshua, and thank you, San Diego State Team Volastor. So there is one subtle point that I need to clarify. Whereas our parent company, Cleantech San Diego, true to its name, is an advocate for all aspects of sustainability, including energy, water, air, and waste, because the SEEN funding comes from the CEC's EPIC grant program, the Electric Program Investment Charge, which is funded by a line item on all California electricity bills. We're only permitted to engage with companies that will ultimately deliver tangible benefits to California electric ratepayers. But I should also note that the CEC has other funding programs that are dedicated to innovations in natural gas and clean transportation vehicles and alternative fuels. And as you can see here, on our 5 block of eligible technologies, our Energy Sandbox covers the full gamut of electrical technologies, including the smart grid and energy services and the EV infrastructure component of clean transportation. And here on our chart of current active SEEN startups, you can see that we have companies commercializing technologies in all 5 focus areas. And I'd like to point out that those companies' names that are circled are companies whose technologies were developed in universities' labs. And as you can see, that's almost half of them. In closing this segment, I'd like to point out that in the upper left renewables quadrant, controlled thermal resources is at the epicenter of California's Lithium Valley Initiative, where they're combining their core competency in geothermal energy with state-of-the-art lithium extraction technology to create a US source of clean lithium to support the growth of the EV industry. Located in Imperial County in one of California's most underserved communities adjacent to the Salton Sea, this project at full build-out will produce 300,000 tons of lithium and support 400 construction jobs and over 1,400 clean energy careers. And this past July, General Motors entered into a strategic partnership with Controlled Thermal Resources for the supply of lithium for their EV batteries. And just this past Tuesday, President Biden expressed his support for this project as a part of the broader US Strategic Minerals Plan supply chain. Our next presenting team is from UC San Diego, and Jamie Au is their lead presenter, who's going to tell us about New Leaf Energy Company.
Thank you, Marty. Hi, we're New Leaf Energy Company, and we're proposing vertical garden systems as a means of renewable energy and wastewater treatment in urban areas. Next slide. When plants have access to excess resources, they excrete these extra materials, such as hydrogen atoms, to their roots. Naturally occurring microbes on the roots of plants consume these excess resources and contribute electrons to the soil, creating an electrolyte. With a cathode and anode connected to this electrolyte, current flows. This is the basis of plant microbial fuel cell technology. Plant microbial fuel cells can also be used to treat wastewater. Plants transfer oxygen to the area directly outside of the roots, increasing treatment quality by promoting oxidation of organic matter and wastewater and helping remove ammonium and nitrate ions. PMFCs are an alternative green energy technology that is carbon negative. As a result, implementation of PMFCs are a type of carbon capture and storage that is utilized by the biomass to produce electricity, following bikers. With PMFCs, we will be helping contribute to the effort of net zero emissions by 2050. Next slide. Here is an example of a basic plant microbial fuel cell in a planter. Next slide. In our proposed vertical garden system, wastewater from sinks is filtered into a drip irrigation system at the top, which is then transferred down the wall, watering the plants while simultaneously being cleaned, where it's collected and recycled into toilet water, for instance. Additionally, cathodes and anodes are integrated throughout the system, providing current to travel from the PMFCs into biosensors, allowing us to monitor electricity output as well as plant health. It then goes into the power grid. Next slide.
Now to get into the marketing aspect of this technology, here's an example of what our product would look like. The idea of a living city isn't new. We've seen a growing trend of rooftop gardens, sustainable building materials, and living walls such as these in urban areas. Customers have shown themselves to be willing to pay for products that look identical to our proposal and have similar installation costs. These living walls have been successfully marketed to governmental, residential, and commercial buildings. However, no current competing company has been able to provide these aesthetics combined with the clean energy and recycled water aspects of our product. In this way, ladies and gentlemen, we find ourselves in a niche and novel market. Next slide. As a business strategy, we've decided to target urban areas, places that have difficulties implementing energy solutions like wind, solar, or nuclear power due to congestion. As our profits stabilize, we can establish PMFCs as a source of agriculture, water treatment, and centralized power for rural and underserved communities. Due to its flexibility, PMFCs can connect to existing power grids or act as a renewable battery in underdeveloped areas. What sets us apart from alternative energy solutions? We are carbon negative, require little maintenance, are aesthetically pleasing, can fit virtually any space, and have the added benefit of reusing wastewater and decreasing the need for AC or temperature control. There are no competitors that offer the range of applications and the long-term monetary savings. From a power source standpoint, PMFCs have been calculated to generate 3.2 watts per meter squared, not including the additional voltage supplied by the electrolytes and wastewater. The only comparable metric would be from the wastewater treatment facilities, which can generate all required electricity from sludge biomass and PMFCs. In a rapidly growing field, we estimate the electrical output will grow yearly with no cost to the customer. Next slide. We estimate an initial cost of production around $40,000 based on the dimensions of an average New York City building. The biggest cost is the vertical plant wall itself and the plumbing required to utilize wastewater. Additional maintenance costs are limited to monitoring biosensors and replacing anodes every 4 to 5 years. The cost to retrain an electrical worker for installation and maintenance is minuscule, preventing job loss during the energy transition. On the right is an equation developed in a market analysis of PMFCs in conjunction with wastewater systems. This can calculate the net present value of the system tailored to each individual customer. Subtracting the average cost of aesthetics and adding the savings on water, electricity, AC, and tax rebates for being carbon negative, we can determine the amount of money the customer will be willing to pay based on their specific needs and dimensions. Next slide. Our success is measured by the implementations of PMFCs and wastewater treatment technology as a source of carbon negative energy to suit cities' needs, helping achieve net zero emissions by 2050. Next slide. These are our references, and if you go to the last slide. Thank you. And once again, we are New Leaf Energy Co. Leaf, laugh, love.
Thank you.
Thank you, UCSD New Leaf Energy team. Great graphic to leave us with. So at this point through my presentation, you're probably thinking, well, all of these resources, everything sound great, but is it really working? And so I'd like to share a couple slides now that will in fact show you how well indeed it's actually working. Let's start by looking at our SEEN incubator's impact in numbers as of the end of December 2021. In calendar year 2021, even with the negative economic impacts of the COVID-19 pandemic, 30 of our 40 member companies raised some level of public or private capital. And through our first 5.5 years of operations, SEEN member companies have raised $268 million in follow-on capital, which is a tripling of the capital that they had when they joined our program, and represents a greater than 50-to-1 ROI on total expenses invoiced against our CEC grant. Our companies have created 525 jobs. 73% of them have diversity in their C-suites, and together they have had 388 patents approved. But perhaps even more important than the impact in numbers is our impact in the energy market transformation. The innovations that SEEN graduates, eMotorworks and Nuvi have introduced in smart EV charging, Zendi's Edison award-winning DERMS platform that accelerates the proliferation of DERs and microgrids, and IV Energy's software platform that enables solar PV to be monetized on multifamily dwellings are just 4 examples of how our entrepreneurs are truly accelerating the clean energy transition. And now looking at the CEC EPIC program holistically since 2012, you can see the magnitude of these impacts statewide, with $3.5 billion in follow-on funding leveraged to create 3,500 jobs that are projected to save California ratepayers $18.6 billion in energy bill savings and over $100 billion in health benefits from improved air quality through 2045. And now I'd like to introduce our 10th presenting team that comes from Stanford University. And Lina Kim is their lead presenter, who's going to tell us about how they plan to launch CHAMI, mechanochemical recycling of LCO batteries.
Thanks, Marty. And we'll dive right in with next slide, please. Lithium-ion batteries, or LIBs, are revolutionizing energy storage across industries with their unprecedented energy density across both volume and weight. Next slide. As a result, we project an exponential growth of the LIB market, primarily driven by electric vehicles, but also by others, including consumer electronics and energy infrastructure. Next slide. Now, unfortunately, and natural resource scarcity, particularly of cobalt, is expected to chokehold LIB growth. So in other words, the supply of cobalt will be outstripped by the amount of cobalt demanded for LIB generation. This limits LIB adoption simply because there are not enough materials to sustain currently projected levels of growth. Next slide. Now, in order to meet the dire need for raw materials, LIB recycling is a growing market intended to meet the demand for raw materials by recovering them from spent LIBs. The growth of LIB recycling will parallel the LIB market, and this represents the market opportunity that we aim to target. Next slide. There's a particularly large potential for lithium cobalt batteries, or LCOs, which are a type of lithium ion battery. Now, LCOs used to be the dominant LIB type because of their predominance in consumer electronics. But these LCOs are now being phased out in favor of other LIBs that are more EV compatible, which makes now the perfect time to work on LCO recycling and recover materials from them throughout this transition period. Next slide. Now, unfortunately, current recycling methods are simply infeasible. They're energy intensive, create high emissions, generate toxic waste, and are procedurally complex, making them both environmentally and economically infeasible. And so, our proposed technology. In the following slides, we'll be proposing a business model for a technology that reimagines the LCO recycling process. This technology combines the first three steps of a traditionally existing processes, which are the most resource and waste-intensive steps, into a single clean mechanochemical step. To give you a quick overview of the tech, LIBs are put through a ball mill to expose the recoverable metals, which are then chemically separated out with safe, non-toxic chemical reactions involving simple metals, inert gases, and distilled water. Our technology beats out traditional competitors like Culture Recycle in LIB recycling by making LIB recycling long-term viable, both environmentally and economically. We're increasing efficiency, removing toxic waste steps of the recycling process, and reducing costs of LIB recycling. And with that, I'll pass it off to Patrick for the next slide.
In order to convert our technology from theory to reality and to achieve success in a circular economy in the LIB space, we propose a three-part plan. First is partner acquisition, second is implementing our technology, and finally is customer agreements. Next slide. First, we want to acquire agreements with municipal waste facilities. These facilities currently pay a premium of around $90 per metric ton for the disposal of LIBs. So we would go in and create agreements that would offer a discounted price to recycle instead of dispose these LIBs. And once we've established a process for LIB acquisition, we move to phase 2, where we focus on implementing our tech. We would take existing processing facilities and retrofit our ball mill technology and equipment that Lina mentioned in these facilities. This transition would potentially require additional personnel as well, and we would focus on folks that might have lost their jobs in LIB disposal to take jobs in recycling. And our final phase is focused on selling our extracted raw materials. We have two targeted customers here. One is the market for raw materials, and the second is LIB and LCO producing partners. Next slide, here's Evan.
Thank you. All right, market sizing. The TAM is $3.6 billion defined as LIB recycling's global market. Of this, a tenth is LCOs, making our SAM $360 million. Given our tech's significant cost reductions, we estimate 50% obtainability for an SOM of $180 million. Next slide. Next is our pricing and the go-to-market strategy. For pricing, we have two revenue streams. First is a removable fee from waste companies. It currently costs them $90 per metric ton to dispose of batteries. We take batteries off their hands for a fee slightly lower than this, using a tiered system based on contract quantity. Second, we sell our recovered materials on raw material markets and to companies producing batteries. Next, our growth timeline, which is fast because we offer a significant improvement with a simple process. We raised 1.75 million of seed funding by late 2022 and launched a pilot in 2023 by retrofitting an existing plant, expanding over the following years. Our analysis estimates cash flow positive by 2024 due to economies of scale. Next slide. Lastly, impacts. First, recycling reduces mining, which is linked with violence, child labor, and environmental damages. Second, we reduce waste because we reduce recycling costs. And so we're going to be reducing disproportionate harm to marginalized communities by avoiding improperly disposed batteries, which would leach into the ground near landfills. Finally, we play a role in the circular economy and are key to enabling increased EV adoption. So overall, we're very eager to play a role in the transition to a green circular economy. Thank you.
Thank you very much, Stanford's Chummy team. In the course of my first 10 team introductions, I've tried to share with you an overview of all the resources that are available to assist energy entrepreneurs in accelerating commercialization of their clean energy innovations. Now, unfortunately, it will not be very practical for you to skip through the recorded version of this 2-hour pitch competition to remember all of these resource contacts that I've mentioned. But in this interval, I'd like to share 2 sources that will deliver much of this information to you automatically once you sign up to their online distribution lists. First, as you can see on this slide, are the CEC's list servers. You can just Google CEC list servers, and it'll give you the option to click through to the listserv homepage where you can sign up for specific categories, including general lists, and that's where you'll actually find the separate tabs for the EPIC and GFO grants. There are also climate change, efficiency, renewable energy, R&D, and transportation listservs. So you just click on the ones that you're interested in, and you'll get push emails from the California Energy Commission. The CEC has also created the Empower Innovation online portal, which has really been set up to be the one-stop shop for all stakeholders in the energy innovation ecosystem. Already with over 2,500 entrepreneurs, researchers, accelerators, and investors, once you register your company and yourself, you can go into your settings to request copies of the individual monthly digests that include key items of interest for startups, another digest for public grants, both state and federal, and another digest specifically on private capital. They also have a national events calendar and even a meeting place where you can network to find potential partners to team up with for grants. So I highly encourage you to immediately register at empowerinnovation.net. Now, once you've signed up to the CEC list servers and empowerinnovation.net, if any of the other topics that I spoke to today resonated with you, then the only other thing you need to do is apply to the CEC Regional Innovation Cluster that serves your geography. Just as an example on this slide, I'm sharing the eligibility requirements for participation in our SEEN program. You must have a business office in the state of California. You must have a business presence in one of our first served counties, and that can be either an office or a key field deployment. It has to be a breakthrough energy innovation that will deliver tangible benefits to California ratepayers, and you'll be given special consideration if it specifically addresses the needs of our most underserved communities. So if you fulfill these requirements and are based in San Diego, Imperial, Riverside, or San Bernardino counties, please contact Natalie Toon, our program manager, to either apply or at least get on our mailing list at this time. If you and/or your business is located in the geography of one of our other innovation cluster organizations, we welcome you to contact them via the contact and website links that we've provided on this slide. I should note that one big difference between our SEEN incubator and the other 3 CEC programs is that we offer rolling open applications, whereas the others conduct solicitations for an annual cohort. So make sure to determine their timing for the year that you'd like to apply to engage with the other cluster innovation networks. It's now my pleasure to introduce Alan Gu from Caltech, and his team is presenting their business plan for Sequester, low carbon capture ready for scale up.
Good afternoon. My name is Alan, and this is $30 carbon capture by Sequester. Next slide. We are a spin-off company from Caltech, advised by Professor Mike Hoffman. Next slide. So we aim to do carbon capture in the oil and gas sector for 2 reasons. One is that there is regulatory pressure to decarbonize in the coming decade, as you might know. Two is that economically, oil companies are paying rising carbon price. This graph shows the California carbon cap and trade price in different years, which has risen to $18 per ton in 2021. Next. If we think of CO2 as a commodity, there's a supply and demand relationship. The total potential supply of CO2 from oil refineries is $4.5 billion per year, while the total potential demand for CO2 for enhanced oil recovery is 5 times higher at $16 to $32 billion per year. We'll get to the enhanced oil recovery, or EOR, in just a bit. We have identified the beachhead market to be the CO2 emissions from one single oil refinery for EOR at $10 million per year. Next. CO2 enhanced oil recovery, or CO2 EOR, is a technology where you inject CO2 into an oil well underground to extract more oil. Burning a barrel of oil generates 500 kilograms of CO2, but it takes up to 600 kilograms of CO2 injected underground to extract that much oil. The 100 kilogram difference means that we can get carbon negative oil and do carbon sequestration while making a profit. The current cost for oil producers to get CO2 is $40 per ton. They have traditionally been extracting CO2 from gas wells or making the CO2 on site by burning something that contains carbon. And the price for them, the cost for them has been $15 to $25 per ton, but the rising carbon tax is bringing the total cost close to $40 per ton. Therefore, they're thinking of switching to capturing CO2 from their own emissions, currently costing also $40 per ton. Next. And that's where we come in with a cost of $30 per ton to capture CO2 from industrial emissions. So on the left is our lab scale experiment, achieving 96% removal efficiency with 0.1 second reaction time. In the middle is a process flow diagram of the proposed pilot scale plant. And on the right is a simulation of the central reactor system where we are optimizing the operating parameters prior to construction. We have filed the provisional patent last year. Next. So we envision this carbon capture system to be an add-on to an existing oil refinery, occupying about 1% of the footprint of the refinery. We estimate a capital cost of 10 to 100 million depending on the existing infrastructure available. The capacity for CO2 capture at a full commercial scale is estimated to be 300,000 tons of CO2 per year. And the associated cost saving for the refinery to do EOR is $3 million per year. The profit margin is estimated to increase by 5 to 10%. Next. Our business model is to license this capture technology to refineries. So for example, if the add-on plant we design costs 20 million, we would add a 20% profit and ask for 24 million. The construction would be contracted out, and once finished, the refinery would operate this add-on with our technical support. For the next step, pilot demonstration, we are estimating a capital cost of 100,000 to 2 million, again, depending on the existing infrastructure. We're currently looking for investment for that, and as well as a demonstration site for this pilot. Next. We have completed our lab scale tests last year, and we're moving to the pilot scale with a more detailed techno-economic analysis. We're estimating to begin full-scale commercialization efforts in 2025. Next. If we can apply this technology at 40% of the 135 refineries in the US, we estimate to reverse 20,000 job loss at those refineries, which amount to 1% of the total unemployment. Those people are often in disadvantaged groups, and we aim to get them back working while increasing sustainability. And we can do that as the cheapest carbon capture technology to date that is ready for scale-up. Thank you.
Thank you. Thank you, Caltech's Sequester team. Well, you know, when it comes to presentations, they always recommend that you save the best for last. And I think I have an exciting final slide that will only reinforce what a great decision it is right now to pursue a career in the energy sector. As I mentioned up front, this California CEC entrepreneurial ecosystem was launched just 5 years ago. And for a majority of that time frame, we were operating under the last federal administration that withdrew the United States from the Paris Climate Accord and continued to support the coal, oil, and gas industries over renewables, hydrogen, and nuclear energy. With the change in administration, not only has the US rejoined the Paris Climate Accord, but the $1.2 trillion bipartisan Infrastructure Investment and Jobs Act allocates billions of dollars to create a new Office of Clean Energy and other carve-outs for transportation electrification, building decarbonization, and clean hydrogen. And while the Build Back Better legislation has been delayed and may be repackaged with the budgets trimmed, I think there's reason to believe that we'll be seeing billions more allocated to this clean energy transition, which will create an equitable clean energy economy for all Americans. So while we're quite pleased with our progress over the past 5-year term at the scene, we're bullish that this new federal funding tailwind, the best is yet to come. And that concludes my formal comments for today. So thank you, and I'll now introduce our final presenting team. It's my pleasure to introduce Leah de Guzman, the lead presenter from Stanford University, who's going to introduce us to Cambio, decarbonizing real estate via retrofits and AI.
Thank you, Marty. Slide, please. We are Cambio, a diverse team of Stanford building scientists, computer scientists, and real estate practitioners with 14 years of collective industry experience. We're passionate about decarbonizing commercial real estate and working alongside faculty and industry advisors with expertise in AI, tech, and green buildings. Slide, please. Why? Because we need to achieve net zero carbon emissions by 2050. Slide, please. And notably, real estate drives 40% of the world's emissions. Slide, please. Luckily, the climate mandate has never been stronger, driven by pressure from government, investors, and tenants. In the last few years alone, we've seen 10 trillion worth of property owners commit to net zero, and the GSA has committed to 100% renewable by 2025. Slide, please. But while emerging technology focuses on energy efficient new buildings, that represents just 3% of US building stock. The other 97% of older buildings operate on inefficient legacy systems, representing an untapped part of the market and 75% of the problem. Slide, please. That's why we're building Cambio, software that helps real estate managers achieve their net zero goals. We believe software is the critical glue missing from the US energy transition and can help the DOE proliferate retrofit technologies and new regulation to institutional landlords, like heat pumps or electrification. Our target customer is anyone with a large-scale real estate footprint, as climate pledges are becoming table stakes, so think Blackstone or Google. So what do real estate managers do today? The current offering, as we've experienced ourselves, is manual, spreadsheet-based, and arduous, involving the engagement of multiple expensive consultants to produce multiple 150-page reports of unranked physical upgrades. And that's where the recommendations end. Should a real estate manager want to act, they need to sort through the reports and run multiple financial model scenarios per building. The result? Fragmented decisions made in silos. Much of the market is priced out or overwhelmed by this offering and therefore does nothing. Prospective customers, including the GSA, note this process could take years. We've heard, I wish someone would just give me the playbook of the top 10 things I need to do in my top 20 lowest performing buildings. Slide, please. Enter Cambio. We're assembling the largest database for commercial real estate retrofits. We'll use NLP to extract data and scrape private and public data sets. Our proprietary engine will then replicate the decisions of a building engineer and investment professional. Thus, Cambio provides a single source of truth for real estate's optimal path to net zero. Slide, please. As an example, let's take a Class B 1990s vintage New York office. Cambio can tell you to install a heat pump to reduce electricity use for heating, mitigate a $30,000 fine that will hit in 10 months, leverage a new subsidy that will cover 60% of the cost of a boiler upgrade. Oh, and by the way, if you do these things, you'll qualify for a green loan and save 30 basis points in interest expense. Slide, please. Now imagine those recommendations automated en masse across an entire portfolio. Think of Cambio as like having a best-in-class building engineer and investment professional all in one, prioritize the highest and best use of time and capital across all assets. Slide, please. Cambio will offer real-time environmental performance, automated recommendations, reporting, and benchmarking, which will holistically drive financial and environmental results for real estate managers. Slide, please. We've determined that the application of big data and AI in real estate retrofits is possible. It's been done before in other industry verticals to this level of granularity, like in mining and oil and gas. Slide, please. Further, the feasibility has been proven out in theory in academia. The scope of feasibility ranges from benchmarking in big data's most simplistic application to predictive models in its most complex. For instance, training models on post-retrofit outcomes. Slide, please. While studies support this feasibility, no player has yet commercialized that research. That's why we're working with our faculty advisor, Scott Brady, an expert in data science and AI. We're interviewing 60 building experts to produce a mind map of all the inputs that they take in and replicate the decision tree that derives the recommendations. Slide, please. The opportunity set in real estate is large. There are 5.9 million commercial buildings in the US. Assuming our price of $2,000 per building, that's a $12 billion TAM. Slide, please. We're differentiated versus our competitors as real estate sharpshooters who provide hard recommendations for improvement versus our competitors who lack specificity. For instance, telling you, here's where you'll track if you cut your natural gas in half, but failing to tell you how to do so. Slide, please. So where we're at. We've built a web app that measures carbon and energy performance and are doing a beta with Stanford's endowment. Further, discussing partnerships with potential customers like Twilio, Ceres Regis, and Google. Slide, please. Real estate is a $1 trillion legacy industry that remains undisrupted, and we're excited to bring a disruptive solution to market. We have 28 years till 2050. The time to act is now. Thank you.
Hi, everyone. So next up, we have the judges' deliberation. And as Marty is off facilitating the final deliberation with the judges, I'm delighted to have the opportunity to present a special guest speaker, UCSD's very own Dr. Anthony Tong, the co-founder of SmartBill, which is a startup created at UCSD. As consistent with the theme of today's event, accelerating the clean energy transition from campus to commerce, it should not come as a surprise that SmartBill is one of the companies in Marty's CEC Scene Innovation Cluster. Next slide. SmartBill is a real-life case study on how a company can leverage all of the resources that Marty has mentioned today to not only advance their technology to the point of field deployments, but also to have come this far with purely multiple sources of non-dilutive grant funding. It is now my pleasure to introduce you to Dr. Anthony Tong, who is the CEO and co-founder of SmartBill. He is developing a low-cost and scalable approach for the repurposing and recycling of electric vehicle battery packs. Welcome, Anthony.
Thank you. Hi, fellow researchers and innovators. My name is Anthony Tong, CEO at SmartBill, and I hope our work and experience are true testimony to how a running and trying to start up company at the Southern California Energy Innovation Incubator feels like. Next slide. So the problem we're trying to address is we see a rapid growth of electric vehicle adoptions to the tune of 1/3 of the transportation by 2030 could be electric. And at the same time, it's create a challenge and opportunity for repurposing and recycling batteries that are gonna coming out of EV traction vehicles. Next one. So how we handle the battery waste streams currently is that there exists of large warehouses that can take a large amount of batteries, sorting through them and storage them, and eventually determine if they can be good for recycle repurposed, and for some portion of them are reserved for return to EVs, providing repair services. And if you want to imagine how those kind of operation looks like, just look up like final scenes of Raiders of Lost Ark. It's like warehouse after warehouse and batteries stock very high. So Smartville's solution is providing an alternative. Instead of doing what we call a static stockpile management, we create a novel class of power interface, DC to AC power controllers and a battery management solution, so that battery comes in can be quickly interconnected and providing access to the utility grid. So while providing those dynamic stockpile management, we can use the operation data from the battery to determine whether we're gonna go to repurposing or recycling, or how much percentile of the battery we can reserve for electric vehicle OEMs. At the same time, we're trying to link up these processes so that we can build those facilities at a positive revenue stream, so that it allows us to build this facility at locations with high population of EV adoption. And next one. So with that, we aspired to extend the battery life, achieve lower cost, sustainable energy resources with renewable combined with energy storage, and at the end of the day, achieve high rates of battery recycling by acting as a collecting and sorting entities for all batteries coming from electric vehicles. Next one. So looking at our timeline, Smartville is a spun-off company from UC San Diego, formed in early 2019s. A lot of the resources and the opportunities Marty mentioned today, we have the honor and fortune to take advantage of. We are the early, I think, second cohort of Cal Seed awardees. We also, at around the same year, become a member of the Southern California Energy Innovation Clusters. Follow on, we also received CEC fundings. One of them allowed us to do an early stage pilot demonstration. Another latest one that we just contracted under the CEC Bridge program, which Marty talked about, allow us to do a scale-up demos at Central California. Next one. So here is a quick snapshot of our project locations. We are working with UC Irvine with a testing program with our minimum viable product under the Cal testbed programs. Very grateful to leverage some of the integrated energy storage system testing capability at UC Irvine with thermal controls, energy management, and a very well versed in battery energy storage scene. Our headquarters is in San Diego here, where we also working with a partner at UC San Diego to do our first pilot program with energy storage product deployed for behind meter applications. We have two more pilot also funded by CEC. Planned one is providing energy storage plus EV integrated charging, and another one to do our mini hub facilities that handle those waste streams of second life EV batteries. And next one. So as you can see, we are university grown, and we are seeing incubated companies, and here is a kind of snapshot of the resources and leverages we've been able to acquire over the years. We are spun out from UC San Diego Center for Energy Research Lab. We'll be able to receive seed R&D fundings and also grant funding from DOE APA-E to develop our proof of concept and validate some of the key IPs in the lab. We also have the fortune to work with the Rady School of Management at the UC San Diego, the lab to market teams, and they provide a great commercialization study, customer explorations. We're still using some of their early interviews and the market reports for some of our commercialization pitches today. Last but not least, we are working with UC San Diego Facility Group to identify one of the earlier market access, which is a behind the meter energy storage use cases. And then we be able to identify a building at UC San Diego Rare Book Archive to perform our first pilot, and which is ongoing and hopefully kicks off next month. Next slide. So at Cleantech San Diego and SINS, we over the years have been beneficiary of receiving a lot of the funding opportunity notifications and the support in preparing a lot of grant applications, including CEC fundings, DOE fundings, and also successfully secure early support from Cal Testbed and Cal Seed. We worked with a lot of the business development and MBA groups, including C2M team at Berkeley has. And we also work with a lot of local entities, including utility, municipalities, universities, and also some of the other companies that are located in Southern California that develop subcomponents that SmartVille might need for their integrated solutions. So we have ongoing partnerships that are introduced by Cleantech San Diego's and some of the future projects as well. Next one. So at the end of the day, I think in the grand scheme of things, it's great to be located in Southern California. It provides the right balance with a talent pools, funding opportunities, and also a wide variety of go-to-market strategies based on your technology. You can go to VC route, you can go to grant route, or a mix of both. And on the other side, at least for my companies, we be able to access some of the early addressable market just because we are located in California. We have highest concentration of electric vehicles. We have new challenges and ongoing challenges of sustainability and reliability of our grid. And nowadays, as Marty highlighted here, we also trying to address the supply chain issues by providing value-added process in this battery circular economy supply chain. So we hope to furthering our development to bring stakeholder benefits in the addressing supply chain risks, providing sustainable energies, furthering electrified transportation, and also identify a business model that we can scale up, because the problem or the opportunities we see in the California will expand to nationwide, even globally in the near future. So next slide. So here is my final notes to all the startup. As I think as a startup or as a innovative team, your work should be naturally lean, focusing on most value-added work. So which means you should be reaching out to a lot of the opportunity in your startup ecosystems to leverage all the resources we have. And I think what Marty and the Cleantech San Diego team introduced are great starting points, and it will help you safeguard your ideas and hope all the team's success.
Thank you so much, Anthony, for telling us about SmartVille. Once again, SmartVille is a prime example of all the resources that Marty was talking about today. I'm going to give Marty a couple more minutes to deliberate and just go over some thank yous for, oh, Marty, are you done with deliberations?
You can go ahead, Chaya, but we have a winner.
Okay, yeah, then we'll go straight into awards.
All right, then. All right, everyone. The judges have come to a decision on today's pitch competition awardees. And we're going to start out with the Technology Bonus Prize semifinalists. As part of the DOE's National University Prize Pitch Competition, 6 of the DOE's departments are offering special $25,000 bonus prizes to one team from all of the national entrants that has the business plan that best supports their most key strategic initiative. Out of our 12 presentations in the California region, 5 teams are working on business plans that address 3 of these department bonus prizes. And so now I'd like to announce our 3 winners who've qualified as semifinalists in these 3 department challenges. First, for the Office of Fossil Energy and Carbon Management, our California region semifinalist will be team number 11 from Caltech, Sequester, low-cost carbon capture, ready for scale up, Alan Gu, lead presenter. So you are our first technology bonus challenge semifinalist. For the Office of Nuclear Energy, our California region semifinalist will be team number 2 from UC San Diego and Cal Poly Pomona, Nuclei Ventures, small molecular reactors, Josh Carter, lead presenter. And for the Solar Energy Technologies Office, our California region semifinalist will be team number 5 from Stanford University and Carnegie Mellon, FUNDUSOL, Michael Bendock, lead presenter. Now, let me explain this a little because it's different from it's a different track from our region winner. From the pool of all technology bonus prize semifinalists, which these student teams are, across all of the 11 Explore events, a single technology prize finalist per technology office will be selected by a team of subject matter experts from that department who will review all of the Explore business presentation submissions. Up to 6 teams, 1 from each department, will be awarded $2,000 and invited to compete in the refine and pitch phases alongside the regional winners. The 6 technology bonus prize finalists will be competing for $25,000 at the finals on March 24th at Carnegie Mellon. And so now it's time to introduce our DOE EnergyTech University Prize California Region Grand Prize winner. And it's now my pleasure to announce that our inaugural EnergyTech University Prize Grand Prize winner is team number 10, Stanford University, Team Chami, Lina Kim, lead presenter. Congratulations. You're going to be receiving a check for $2,500 from the Department of Energy, and you're invited to present in the finals during Carnegie Mellon's Energy Week on March 24th. I'd also like to mention that our judging teams wanted me to make special mention that teams EcoBreeze, GOS, and New Leaf Energy Company also did a fantastic job. But as you can imagine, it was a very tough judging decision and very close. So what comes next? Our 3 technology bonus prize semifinalists need to keep an eye out for a communication from their respective DOE technology department to find out if they are selected as a finalist to proceed into the refine and pitch phases of the competition. Again, that can't happen until all 11 regional Explore phases are done. And for Team Chami, you can expect to be contacted by the DOE to be introduced to subject matter experts in your field who will provide mentorship and free access to the Office Technology Transfer's Energy I-Core curriculum to help you refine your presentation for the March 24th final pitch competition at Carnegie Mellon, where the national first prize will be awarded is $50,000, the second place award $15,000, and the national third place winner $5,000. So good luck to all of our California region teams that advance to the Carnegie Mellon finals. And now I'll throw it back to you, Chaya.
Thanks so much, Marty, and congratulations to all the winners and everyone who presented. I would like to start off by thanking the judges for taking time out of their busy schedules and choosing our regional winners today. Next slide. I'd also love to give a big special shout out to my co-MC Marty and the Southern California Energy Innovation Network. Next, I'd like to thank EnergyTech sponsors for making this event possible. And I would also like to thank the UC San Diego campus partners. Next slide. I would also like to thank the participating universities in today's competition, as well as all of the teams who entered the competition, even if they did not present today. And then lastly, thank you all for attending today's event. We hope you enjoyed hearing everyone's innovative ideas from our university students. I know I did. So thank you all for a wonderful event and have a good evening.